but it's not bad at all, I promise. Okay, so what a deviation is. A deviation is the difference between a data value. So if you had a list of data, just one of the values, the difference between one of your data values, which I'm going to call that just X to represent a data value, and the mean, which we can use that little X bar to represent, which you're going to see those two things in that lovely little formula that looks super complicated, but don't worry, don't worry. So a deviation, difference is subtraction, right? So it's your data value minus whatever the mean is of the data set. That's how you would calculate a deviation for a specific data value. So it's just subtraction. Now, you guys are probably looking at this like, what the heck? Okay, so standard deviation and variance. We're just going to talk about variance here real quick. X bar, that's the mean in the data that we would have. So we'd have to know the mean to do this, and you'd have to have your data items. Okay, what they call the variance, and the reason I put this little symbol here, this is what the symbol is that you're going to look for in the graphing calculator if we do this with technology. We're going to do it by hand first. But this symbol is called, this is a Greek letter, it's sigma, if you, well, we already know this, okay. So, did you see this in like chemistry or physics or something? Yes, it just means you're gonna, sigma, it's just the sum. You're just gonna add up all the deviations, okay? So, all the deviations from the mean, we're gonna add them up. All right, now, the variance is the sum of the squared deviations. I'm going to explain that in a second, but that's what this says, just to explain it, sum of the squared deviations. Variance is the square, so like to the second power of the standard deviation. Both of these measure spread of data, but standard deviation is typically what they use to actually kind of compare things. So standard deviation, so the variance is the square of the standard deviation. So the standard deviation is the square root of the variance, which you see above there is that exact same formula. Don't worry, it's not going to look that complicated when we actually do it. That formula just has a square root under it. We don't do a plus minus. You can't have a negative standard deviation. Okay, now the greater the standard deviation, the more spread out the data is from the mean, basically. So the bigger your standard deviation, the more spread out your data is going to be. We're going to do some stuff today to show some visuals of this to hopefully make this look better. Okay, now I'm just going to put like a little thing here. There are actually technically two formulas for how to calculate these. Okay, we have what we call sample standard deviation. I'm just going to write SD. Now, if you guys are looking at your calculator, in that menu where we were doing the stuff yesterday, that actually has a notation that looks like S sub X. Okay, that is not what you're going to want. We're going to use population standard deviation, which is that symbol. So the one we're going to use is this, but there, I just want you to know there's two different ways to calculate it. The reason we're not using Desmos to do this is because Desmos calculates the sample, where we're going to calculate the population, because we're going to have the entire population of data to work with. Okay, now I'm sure I just made that sound super complicated, but we're actually just going to go through here and we're going to find the standard deviation and the variance for this little data set. You don't have to put them in order from least to greatest. I just got a list of tests here. The first thing I'm going to do is just find the average, because you need to know the mean to be able to do the standard deviation and the variance. To find the deviations, you need the mean. So I'm literally just going to do this by hand. So I got 89, 79, 74, 67, 99, 91, 84, and 81. If you want to type that in the list that we did yesterday, you could do that as well. I'm just going to do it by hand here real quick. But it looks like we have how many? 1, 2, 3, 4, 5, 6, 7, 8 test scores. So just to find the mean here, we take the sum of the test scores, which is that 664, and we've got 8 test scores going on there. So the average is 83. Okay, now to find a deviation, here's what I'm going to do. I'm going to just write these out kind of vertically. Doesn't matter the order. You got an 89, you got a 79, 74, 67, 99, 91, 84, and 81. So I just rewrote the test scores. Okay, now the deviation, make sure I spell it correctly. The deviation is the difference between the data value and the mean. All right, so all you're going to do, you take your test score and you subtract the mean. So that's why I calculated that first real quick. So if I subtract that, that's just 6. All right, if I do 79 minus 83, and it's okay for these to be negative. So I got -4 there. You take your data value minus the mean. And it's okay to be negative, it's okay to be positive. So if I do 74 minus 83, I'm going to get -9. 67 minus 83 is going to give me -16. 99 minus 83 is going to give me 16 also, or it's positive 16. 91 minus 83 is going to give me 8. 84 minus 83 is just going to give me 1. And 81 minus 83 is going to give me -2. So if you were looking up above where I wrote the data value minus the mean, that's what you're doing if you calculate a deviation. How far away is that test score from the average that you have? Okay, now the third thing I'm going to write down, you just need the deviation squared for each one. If you come back up to these formulas up here, it's going to be an average of the sum of the squares of the deviation. The reason they square that is because that'll cancel out all those negatives that we have. So what I'm going to do here, like the square of the deviation, this would just be 6 squared, so it'd be 36. -4 squared would be positive 16. And then on down the line. So basically squaring it is just going to cancel out any negatives that you have. If you square 16 or -16, you're going to get 256. Eight squared, 64. I think I still have some of these numbers up on the board. 1 squared is just 1, and -2 squared is 4. So deviation is just the distance from the test score in this case to the mean, which is 83. Deviation squared, you're just going to take all those numbers we did in that middle column and you're going to square them. All right, now here is how you calculate the variance and the standard deviation. Sorry, I should have jotted this down. We already calculated the mean, that was 83. Now, the variance is the sum, it's the average of these deviations squared. So to calculate the variance, you're just going to add all these up, and then we're going to divide by 8 because there were 8 test scores. It's just an average of the squared deviations. So I'm just taking 36, 16, 81, just adding these up. 256 twice, 64, 1, and 4. So total, if I add these guys all up, I get 714. And then I'm going to divide that by the number of data values. We had 8 test scores there. So I'm just doing 714 divided by 8. I got 89.25. That is the variance. Now, to do the standard deviation, the variance is the standard deviation squared and the standard deviation is the square root of the variance. I'm not on the screen, forgive. So what I need to do there, just basically because we squared all those deviations, now I'm going to take it back into single by taking the square root because we squared all those deviations. So I'm just going to do square root 89.25, and I'm just going to go 2 decimal places on here if it doesn't tell you any different. This is 9.45 would be our standard deviation. I know that's, it's kind of a lot of work if you have to do this by hand. So I'm going to show you how to do it with the calculator on the back, but that's what the process is. Find the deviation, you square all of them, and then it's just the average of the squared deviations to find the variance. You take the square root of the variance to find the standard deviation. Okay. Now, on the back, I'm going to show you how to do this with the calculator, but we're going to compare these 2 data sets. So this just gives you a little, this is called a dot plot. So just dots of people's heights on 2 different basketball teams, so you guys can compare them. And you can probably kind of see visually from these kind of how, like, is the data more spread out or is it more in the same place? And then we'll compare the standard deviations as we look at this. All right, so I'm going to write down, because they don't list the heights, I'm going to take this dot plot and I'm just going to write down the heights that are given for these people. These are their height in inches. All right, so on the Pacers team, there's one person that's 69 inches, and then next to that there's 2 dots, so there's 2 people that are 70 inches. One person is 72 inches, one person is 73, one person is 74, and then 5, 6, one person 77, 2 people 78, and one person, oh, I'm sorry, I'm not on the screen, 79. All right, so I'm going to show you guys how to do this with the calculator instead of doing all those deviations by hand like we just did. All right, so find the mean, the standard deviation, and the variance. So I'm going to do what I did yesterday. I'm just going to go to Stat, and I'm going to go to the Edit menu, just the first one, hit Enter. And if you have data in here from yesterday, I'm just going to arrow up to the top, hit Clear, and hit Enter. You have to hit Enter, it'll wipe that whole column out. And then just in case, did anybody accidentally like delete their column or it doesn't start with list 1? Let me just show you this just in case. Yeah. If you hit that Stat button, just that Stat button, if you accidentally delete something and you didn't mean to, that's just hit Stat. Do what? Okay, yes, I will show you in 1 second. Okay, if you have a list that's deleted, on this main menu here, the last option says Set Up Editor. If you just arrow down to that or hit the number 5, just hit Enter twice and that'll reset that entire screen. So if you accidentally delete one of the lists out, you can get back to it and restore it. Like I'll go in here and I'll show you. Like let's say I accidentally went up here and I pushed delete and now my lists start with list 2. If I do that, just hit that Stat and then Set Up Editor. It's just like a reset button. You hit Enter twice, and then if you go back into that Edit menu, that'll restore anything that you maybe accidentally deleted. Now, if you've got stuff in the column here, like if I have some data, I'm just typing some numbers in, just arrow up to the top. Don't hit the delete key. You want to hit Clear. It's right underneath the bottom arrow. Hit Clear, hit Enter, and that'll wipe out anything that's in the column. You can type over the top if you want to, or I just usually start from scratch and just delete. So then I'm going to put these heights in here real quick. Just hit Enter in between each one. And even the last one, you have to hit Enter after that. So there's 10 people represented here. So you should have 10 heights in your list. Once you're there, you just Stat, arrow over to Calc, and you just want that first option, one variable stats, and then just keep hitting Enter on that screen till it shows up. Now, the mean, remember, that's the X bar at the very top. So the mean here is, actually it's a nice number, it's 74. So if I wanted to calculate the deviations like we did on the front, I would take each one of these numbers, subtract 74 the deviation squared, then we would just square it. If I want to just use the calculator though, the standard deviation is going to be the little symbol, not the SX, but it's like a little Greek letter, like a little cursive OX. That is what you are looking for, and I'm just going to go 2 decimal places, about 3.58. And that 3.58, excuse me, is going to give you your standard deviation. Now, the calculator does not display the variance because the variance is really just used to calculate the standard deviation. So if the question asks you for the variance is going to be the standard deviation squared. So if I need the variance here, you can grab that from that calculator screen. Should just be that 3.58 squared. So if I want to just type 3.58 squared, whoops, oh, I just hit the wrong button. So variance here, if they ask you for that, is about like, I don't know, 12.82. I'm just going to go 2 decimal places on these. So it's a little bit faster than doing all that work we did on the front, if you guys can use your calculator for that. All right, so see if you guys, I'm going to write down the heights of the Lakers and see if you guys can go through and do this on your own. I'm just going to write it up here and then we can check and make sure you guys are comfortable with the calculator. But the Lakers have the same number of players. They have one person that's 69 inches, one person that's 73, and 1, 2, 3, 4, 5, 6. If you're, sorry, I'm not on the screen. If you're looking at the dot plot, you would have 74. There's 6 people at that height. So I'm going to do 74. I'm going to write that 6 times. You have one person that's 75 and then one person that's 79. Okay, so see if you guys can do that process. And I'll just show you one more time. If you go into Stat and edit to edit the data, just arrow up to the top, hit clear, hit enter. That'll wipe out all the Pacers. And then you can put the Laker heights into your column there. And let's just, in standard deviation and variance, let's just round those to 2 decimal places if they're not nice numbers. Most of the time they're not. And I'm going to ask you 3 things. Can you tell me the mean? Can you tell me the standard deviation? And then can you tell me the variance? The variance is the only one you shouldn't be able to see from the calculator screen if you're using the calculator. If you're doing it by hand, you would calculate the variance first. So see what you guys think. Anybody get the mean for the heights for the second team? Like what the average was? This one should be 74. Did anybody get the standard deviation? 2.28, yes. And then all you have to do, is anybody not getting that? I'll come look at your calculator if you're not. And then just to get the variance, you just take that 2.28 and we're going to square it. So let's say like 5.2 to 2 decimal places there. Okay, now what do we use the standard deviation for? You guys can kind of see on these dot plots, like the Pacer heights, right? They're way more spread out, right? They go all the way across the number line. They're spread out. And you'll see that their standard deviation was 3.58, whereas the Lakers, their standard deviation, most of the people on this team are in that center part of that number line there. Most of their heights are there. So their standard deviation is much smaller. So this is telling you the bigger the standard deviation, the more spread out the data is. The smaller it is, the more concentrated it will be. And you can kind of see that visually with those 2 plots up at the top. Now, I'm going to have us do this just real quick to figure out how many standard deviations away are you from the mean. All right, so the Pacers. their standard deviation, we rounded that to about 3.58. Okay, now I know there's like a lot of space here and I'm gonna kind of go in the middle. So the mean for the heights of the Pacers was 74. Okay, now you'll see stuff that says like within one standard deviation of the mean or two standard deviations of the mean. What does that actually calculate to be? So what you're gonna do is you're gonna start with the mean, and on this end, I'm gonna add the standard deviation, which was 3.58. On this side, I'm gonna subtract 3.58. All right, so if I do 74 plus 3.58, that'd be 77.58. On the other end, if I do 74 minus 3.58, you're going to get 70.42. Okay, so this would be within one standard deviation of the mean. Then I'm just going to repeat that process. I'm going to add 3.58 on the right side, and I'm going to subtract 3.58 on the left side from those two numbers I have. So 77.58, add 3.58. This would be 81.16. And then on the other end, the 70.42 minus 3.58. These are not always nice numbers to work with. 66.84. All right, so all the heights here would fall within two standard deviations of the mean. So let me go up. It says the heights of all the Pacers fall within how many standard deviations, excuse me, of the mean. If I go back up to that graph, the shortest person 69 inches, the tallest person 79 inches. Do I have everybody covered within one standard deviation? No. Do I have everybody covered within two? Yes. Okay, so within how many? This would be two. You have to go out two standard deviations to cover all the people on the team. Okay, now the Lakers had exactly the same maximum and minimum. So we're going to see how many standard deviations we have to go out for them to cover all the people's heights. So the average actually was the same for the Lakers. They were 74, but their standard deviation was 2.28. So I'm just going to kind of repeat that process. So I'm going to add 2.28 and I'm going to subtract 2.28. Those values will give me within one standard deviation of the mean. So this is going to be 76.28 and this is going to give me 71.72. Okay, definitely not covering everybody, right? The shortest person was 69 inches, the tallest person was 79, so we got to go out farther. Okay, so I'm going to repeat the process. So standard deviation here, whoops, was 2.28, so I'm going to add it and I'm going to subtract it on both ends. So 76.28 plus 2.28, this would be 78.56, and 71.72 minus 2.28, 69.44. So within two. Do I have to go out farther? Yes, because we had a 79 and actually on the other end we had 69. So I got to do this one more time. So I'm going to add 2.28. This should be enough. So on this end, you'd be at 67.16, and then on the upper end, I would be at 80.84. But here I have to go out 3 standard deviations. It's like one on each side of the mean. So within 3 standard deviations, then I can cover the heights of all the people on the Lakers. Is anybody having a question?